Okay, so what I'm going to do in these videos is just run through quickly the core skills that you need in R to analyze both cross-section and time series data. If you need more detail, more information about various aspects of R, then have a look at the other tutorials I've done on here under the playlists R Tutorials Fundamentals and R Tutorials Advanced. So in these first two videos, I'll look at how to analyze the sort of data, cross-section data that you would typically collect via, say, a questionnaire from a survey. So first of all, I need to input the data. So the easiest way to do that is using a CSV file. So set up your CSV file so that each variable is in a column, and in the first row you have the variable names. And also make sure that the data file, the CSV file, is in your working directory so that you only need to specify the name of the file. If not, you'd have to put the full path. So using the read.csv function, you specify the name of the data file, comma, header equals true to pick up the variable names, and strings as factors equals true so that categorical variables are turned into factors. And then store that in that will import as a data frame, which you store in a variable such as one here called data. So we can have a look at the data by displaying it on the console. So as you can see, it's a simple, I've used this little file, this little data set before. It's just a very simple data set with 3 variables, 2 categorical, 1 numeric, simply 20 cases. Obviously, in practice, your data set will be presumably much larger than this, with lots more cases, perhaps even thousands, and lots more variables. But the same principles will apply, so this will do fine for illustration purposes. Now, there are 2 commands that it's useful to run immediately on your data set. Firstly, str, to look at the structure. And that simply confirms that how many observations you've got, how many variables, what the variables are, gender and site, which say have been turned into factors, which is how R handles categorical variables, and this one is simply a numeric variable containing integers. The other command that's useful, the other function, is summary, which will give you some summary statistics like that. So for a categorical variable, it gives you a sort of frequency breakdown here. For a numeric variable, it gives you these descriptive statistics here: minimum, first quartile, median, mean, third quartile, and maximum value. Now, what you typically want to do with categorical variables is, first of all, do a frequency breakdown. We've actually got them here, as you can see, but if you want to create that so that you can then chart it, you use the table function. So you simply use table, then you specify the variable. Now, to specify a variable in a data frame, you put the name of the variable containing the data frame, $, and then the variable name, in this case gender. So that's going to create a frequency. It's going to create this little frequency table here, which I'm storing in this variable here. And then I'll display it, and there we are. As you can see, here's the breakdown again. Now, the reason I've done that is so that I can then plot it as a bar chart, simply using the bar plot function. Like that. As it stands, it's very basic. It doesn't have a title or axis labels and so on. We can tidy this up in a moment. Now so that's for numeric variables. You want a frequency breakdown, categorical variables. For a numeric variable, you typically want to display a histogram. Use the his function on that numeric variable, and we get a nice histogram, which is quite reasonable already, but we can also improve this, the display of this. Notice by default it gives you the frequency, the number of values in each interval. If you want the proportions, simply use the same function but set the FREQ option or argument equal to false. And as you can see, that now gives me the same thing but with proportions, with densities. So very easy to create frequency breakdowns and charts and histograms of these variables. Now, the next thing you probably want to do with your categorical variables is to create some cross-tabulations. So here I'm going to cross-tabulate gender against site. So it's the same function table. You simply specify the two variables here. And I'm going to store that in cross.tab and then display it. And then we have my little cross-tabulation of gender against site. That's showing the number of values in each of these cells. If I want proportions, use the prop.table function on that cross-tabulation. Like that. Notice I didn't store this in a variable, so it's actually displayed it immediately. It might have been better to store it so that I could use that variable later on. Now, one thing missing here from this cross-tabulation are the row and column totals. I can add that using the add margins function. So applying that to my cross-tabulation, storing it in this variable here. And then if I display that, then here we are, the same thing, but with the totals, row and column totals and the overall total. Again, I can do that to this one here by using the add margins function. Notice because I didn't store that in a variable here, I've had to put it in again. If I'd stored it in a variable, I could have just put the variable name in, which is probably better. And there we have the same thing, but with the row and column totals. Now, just like we use bar plot to draw a bar chart of a frequency breakdown, we can also use it for a cross tabulation. So here I'll plot this one here. Like that. Notice by default you get stacked bars. If you want them side by side, which I think is better, just use the beside equals true argument. Like that, and that's much better. Of course, it's still not great because there's no title, and clearly we need a legend here so that we know which of these bars represents male and female. We've got the site values here on our horizontal axis, but we need to know what these bars mean. And I say a title would be nice. It's easy enough to do that. You just need to add additional options to the bar plot function. So here I'm using main equals to set a title, ylab to give me a y-axis label, legend.text to give me a legend. Now here you specify a vector, so remember to specify vector, you use little c and then in brackets the elements. So I put female and male. Make sure you put those the same way around as the bars here, because this is female first and this is male. Beside equals true, of course, to get this, and then I've also specified the colors of the two bars here using the col function and a little vector here. So that will give me the same chart, but much nicer now. Proper title, proper y-axis label, a nice legend that matches up. So clearly very easy to create a cross-tabulation of a couple of categorical variables. And if you want, you can of course carry on various statistical tests here, such as the chi-squared test. That's very easy. The function is chi-squared.test. So applying that to my cross-tabulation here, we can apply that. And there we have the result with the test statistic and the p-value. This warning message here is simply because the data set is a very small one. It's only got 20 cases. You need more than that to do a chi-squared test properly. So with a larger data set, you won't get this error message. So as you can see, very easy to do that kind of basic analysis. Now what about the numeric variable here? Well, there are a number of things I could do here. First of all, I could just find what the average usage is, looking at all the respondents all together, so simply find the average of these values. I can do that simply by applying the mean function to that variable, like that, which shows me that the average was 31.95 hours per week. But what I also might want to do, like I did here with these cross tabulations, is to break that down by gender or by site or by gender and site. So if I want to, say, show average usage broken down by gender, use the tapply function, and there, to do that, you specify the numeric variable that you're wanting to find the mean of, or whatever function you use. In this case, I'm going to use mean. You then specify, in using this list notation here, the particular variable or variables you want to break it down by, and then finally the function you want to apply. So in other words, I'm going to find the mean usage by gender here. So running that and then displaying it, that's, you see exactly what we get. So here we've got the average usage by females and the average usage by males. Now, say I could also break this down by site as well, by another categorical variable. Exactly the same. All I need to do here in this list function here is specify the other variable. So I'm breaking down by gender and by site. And then displaying that, and exactly what we get. Now, of course, these cross tabulations, I suppose they are cross tabulations, yeah. Here can be, of course, displayed in a bar chart like we did with the ones up here. And again, it's exactly the same bar plot. Put in the variable containing your cross tabulation and then specify these various options. The only one I've used here I didn't use before was y-lim. That specifies as the scale of, in this case, clearly the y-axis. If you wanted to specify the x-axis, you put x-lim. So I've set that equal to go from 0 to 50. Notice you specify it as a little vector, which works nicely because the biggest one is 48, as you can see, so 50 is just enough. I could have let it as the default, but that wasn't as good, so I've specified it separately. And there we are. So a very nice chart again, showing the average, the mean weekly hours, broken down by site and by gender. Okay, so that shows you how to do some basic analysis. In the second video, I'll look at how to subset your data.